Alright, I'll be uploading it somewhere once I figure everything out. Yeah, so yeah, it's her core light. So in this case, the information that he sent over was this sample was distributed using a watering hole attack, targeting a common resume collection application Salesforce with a specific plugin. The application is an HR tool which can query resume scraping services in order to automatically aggregate a pool of qualified candidates. So we see essentially it's like related to HR. Hey folks who are just joining. So in this specific case, the application essentially opens a zip archive and like parses some contents client side. The TA uploaded a malicious zip archive in an SCR payload inside, disguised as a PDF inside. So there is a bit of like some funky stuff going on. And finally, he said, because the vector is a watering hole attack, and considering that this sample attempts to blend in before executing, I decided to give it the nap name for its circumstances, Crocodile Rock. Because you get rocked by an ambush predator. So this was fairly neat. So on my end, I have already downloaded the sample. I'd be posting it in the chat if someone's curious to kind of look at it. So throughout this stream, I will kind of try to, run you guys through my thought process. Just because I know Frog was kind of curious to understand how I would approach that sample and everything. So I'll try to be honest as possible. I didn't look too much at the actual sample, so I might end up looking like an asshole and not being good at anything. But that's part of the game, right? So let me just quickly spin up WSL so we can start by at least looking at the file. So that should be somewhere there. So in this case, the initial file was the this one, which I had deleted, but if I'm not mistaken, it was this file right there. So let me just grab the raw link so we can download it and unzip it ourselves. Let's do a quick. Oh, is it just copying the raw file? Come on, man. Can unzip it. I'm assuming the password was infected. So now we do have like this weirdly named file. So if we take out the old one and with the new, maybe I can make this a bit bigger for you guys. So we see that it's still like a zip archive, so we can just quickly do that. And we are left with an SCR file. So let's just delete this bad boy. The first thing I initially did was just running it through the IC, which is detected easy, but for the console essentially. We quickly see that it's C++ compiled most likely with Visual C++, and C++. It uses most likely Microsoft Linker, so nothing like super fancy there. If we are curious, we can also load it in the UI version of it, which should bring us right here. So we see the same information. If we look at the actual PE, typically the first things I look for are just like the headers out of curiosity. So in this case, we don't see much. There's not a ton of information that's super helpful. We know it's not a DLL. It's an executable image. The redocs have been stripped. See, it's not that big of a binary, and if we look at the imports, we do see it does like use a bunch of them. So we have like kernel 32, user 32, shell 32, OD 32, all of that fun 32-bit stuff. And bunch of wet frogs says some context for the initial file on disk on Windows without file extensions enabled, disabled by default. It has an Adobe PDF icon, and that fake .pdf extension is to attempt to mislead user. Yeah. So if we look at it in our file browser, I'm not sure if I can get it like big enough for you guys, but it's got like that kind of shitty icon on it. So in this case, as I mentioned, like there's a bunch of imports, but what we will quickly realize if we open this in Binary Ninja is that it is most likely packed. Let me just make sure I get the right file for this one. Let's just let it analyze it real quick. Alright, so if we go into our start, we see initially there's two functions. Maybe I can zoom it a bit for you guys. Is it too small, or does it kind of make sense like that? Anyways, so we can see it a bit bigger, won't it? Okay, let me just try and find where I can make the font bigger. Do I have some settings somewhere? Settings. Can I do something like font? Application font size. Can we do like 14? Oh, can I just zoom in through window? Oh, hold up. It seems like grayed out for some reason. Where was it? Let's just restart it real quick. See if it's better. Looks the same. Okay, it's just the outside now. Can I do settings, font, view font size? Let's put that at like 12. Should be better. What are you guys up to other than staring at my screen? Alright. So that should be slightly better. So in this case, we quickly notice that we have like two functions. The first one is just some security cookie stuff. So initially I just kind of ignored it because that's not something I'm super interested in yet. And then if we enter the second function, which is var1c7f, we do see that there's like a bunch of stuff. So we see like a call to heap init, which essentially just initializes the heap. And then we see a bunch of like FLSLoc and TLS stuff that gets allocated. So once again, you know, I didn't give that too much of a thought initially. If we continue a bit below, we see just some random values being returned there, so not too interesting. We see that there's a structure being defined there. Another one, we get some information on the type, on the file. We see that we set up a reference to command line A through this pointer, so we can just like rename it actually get command line A. And then we have this bad boy, which we can assume is essentially just a wrapper around get environment string W that deals with like whitechar and multi-bytes. So we can probably just like rename this one get command line, and let's just give it a MW prefix so we know it's something custom, and then we just do get, oh sorry, it was it environment? Moving on, we see that, you know, get module file name A is called on this file. We don't see a ton of references to it. I guess we could check what data. In this case it's uninitialized data. So we do see like a few things going on, but in this case I do want to just like show what kind of gave me the impression that this was packed. So we can move on, and we see there's a bunch of stuff going on, but if we actually look through the strings, I do recall seeing some references to like MSIL in there. Attempt to use MSIL code for this assembly during native code initialization, and then we also noticed at the, I think it was like the very bottom, so we do have like multiple big blobs of bytes, like this one, which is like fairly long. And me being a lazy person, I decided to just shove it into Unpack Me out of curiosity. So for those that don't know, Unpack Me is an unpacking service that was built by two very cool folks. In this case, let me just log in and I'll show you guys what the results came back to. So we can just drop our file. Should be somewhere in there. Our study. So we have our SCR file right there. And if I just go into my history, we should have the same sample, although unpacked right there. Alright. So we do have a bit more information on the parent, such as like file version information and stuff that we could typically find through Detected Easy. Let me just reopen my screen. New question: what made it look back during the initial look over? Sorry, I missed that, but I'm guessing what I just showed somewhat answers your question. So let me just get back to this. Alright, so in this case we do have an output. It's currently identified as Hancitor by ClamEV, but a bit hit or miss on that part, I'm not sure exactly. So knowing that Unpack Me was able to actually unpack it, I just kind of went down the lazy route of downloading it. So in this case we're going to end up with something that is much cleaner. Let's just get a sample right here, and let's let Binja do its thing for a second. So already we see that we have a lot less functions. We have like maybe like 20, something like that. So initially what I started doing was just kind of browsing through the functions to see what comes out of it. So already we see some references to LDR data table entry, and then a second pointer, and then we see that there's a while loop right there that iterates over the f-links. So someone could like fairly quickly assume that this is just like pip crowding for the modules. Um, so yeah, and then we see that there's a bit more of a routine there going on, potentially some XORing of some data or something, and all of that. And if we look into this one where it just takes uh, the first f-link value, okay, so it will take the last one. And it will run this function, which as we see is just essentially doing a bit of math with two what seem to be constant variables. So in this case, my first kind of instinct was to just shove it into Google to see what came out of it. And we like quickly noticed there's a few mentions to FNV1A. So this is just a hashing algorithm, essentially. So if we look at like this example, we noticed that there's those two constants, essentially, as we saw in Binja. So our, a good guess here is that they're essentially using FNV1A. So we can just go back and with hashdb start resolving a bit of stuff. So we can go into hashdb. Oh, well, I think there's a better way actually. So we can just do a hunt on it, that specific hash. It will do its thing, and it's got a 100% hit rate on FNV1A. Yeah. So these would be like the kind of two ways to try to identify these hash. One of them is just through the hashdb plugin, and the other one is just by essentially looking for constant values. And thanks, Becky, for pointing out what I was just talking about. So we can set the hash algorithm to FNV1A, and then we can just like start resolving some stuff. So we can do a hash lookup. In this case, it's being identified as kernel 32. And from there, did it create a enum for this one? There we go. So it identified this function as being load library A. And if we look at the function, because I'm curious to see how it's going to be returning that value, we see that there is an exit process where it doesn't return at all, or it returns this mess. Typically, I would be tempted to like set result to, in this case we know it's like load library, so I would be tempted to set the type of result to load library's signature. So if we look at the MSBN, normally we could essentially just like take this signature, and yeah, as Becky is DMing me on an H module is essentially just a glorified p-void. So it is similar, but Binja may have misidentified the actual type. So I'm just going to check how the return value is going to be used, just to make sure that it's actually returning the function and not a weird version of that function or whatever. So in this case, we see that result is right there, and it's being called with only one variable, which somewhat fits what we're seeing with load library. So for this one, I'm going to just like go with it and see what comes out. So we could just retype result right there as load library. So let's just do this. And for those that don't know, Binary Ninja can take in like just the syntax that's provided on MSDN, and then it's going to recommend you use a pointer instead of the actual function. So that works for us. And we see that now load library is being called with lib file name. And lib file name is being defined. Okay, so it's a buffer of 40 characters. And does it get filled with anything? Okay, so it's calling load library. Hold up. And let's call that so that works. We see that it is also being called on R2. This is giving us a hint that every time that sub 401 blah 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 is going to call, the second argument is always going to be the hash of the function that we're looking for directly. So for a bit I kind of got tripped up on this whole routine, but knowing that argument 2 is passed directly to our fnv1 hash function, we can just pretty much ignore that. Let's just tweak this one because the signature is a bit off right now. Just call it like vote pointer. Yeah, like that. There we go. So from there, we can just, let's call it rename this one. This will be our hash. arg1, what is arg1 gonna be? So we see it's ECX, and it gets referenced with the file name. We could potentially, like, my first instinct is that the value that we see right there is just the library name itself, so like kernel32.dll or something like that. So I think we can just ignore this for now. So if we go look into one of our other functions, let's start with the first one, not interesting. Second one, not too much yet. Alright, so for this one we could do another hash resolution. We see it is coming out as something in crt.dll. Alright, so that should just be a sprintf. And it is going to sprint. Interesting. Alright, so sprintf does take variadic arguments. So in this case, it is going to be taking 3 arguments actually. I'm not sure how I could fix this one because it's just using the return. Hold up. Yeah. Alright, so let's just rename it to sprintf. Oh, there we go. That's already better. Nice. So we see that is going to pass in the first argument, what is 08x. So it's just gonna be like the okay, yeah, 8 characters wide of hexadecimal. Alright, so we know that this function will just be printing stuff, right? Okay, interesting. And then if we look at this one, we have a bit more hash resolutions to do. Good feeling that's also gonna be sprintf. Yeah. Cool, so we see a bit more printing. We see post being given as an argument there, so this is probably related to some HTTP connections. I can try and look at this one. Nothing yet. Alright, and what are you like doing when the actual, hold up, okay. So we have internet open A right there that is being called with these functions. So what we want to be doing is just going to check the signature of internet open A. So we see that the first one is going to be LPSZ agent. So it's pointed to an ultimated string that specifies the name of the application or entity calling the WinNet functions. Okay, so it's the user agent. Let's keep it simple. So we see that the user agent is being generated most likely by this function with 6 and 41 as arguments. Let's see if we can get something out of this. So that's our local lock. Okay. Let's ignore this one for now because we just know it's the user agent. Let's call it like something user agent. And then the other variables, we see that this should be the DW access type, which is going to be a D word. So we can already retype this one like that. Let's just go with this for that now. This one is going to be the proxy, and we see that it's being referenced right there as localhost 8123. So we could also set it as an LPC string. Let's call it proxy. var34 is going to be the LPSC proxy bypass. This one I'm not too familiar with. Pointer to an alternative string that specifies an optional list of host names or IP addresses or both that should not be routed through the proxy. Okay, so it's essentially just a proxy bypass, right? Yeah, I'm sure someone smarter than me could correct me, but this feels like a proxy bypass. Let's call it proxy bypass. Let's set it as an LPC string. And finally, this one is not set, so that is good. And we know that internet open A is going to return a handle, an H internet. Do I have this? H internet should just be like a handle, right? What's it called again? so let's just load the type that is potentially missing. It should be in like WinINet, like that library. Is it WinINet? It's not that one. Oh. Well, fuck it. Let's just call it void pointer. Alright. So we see that it is calling once again internet connect area. Yeah, okay, so if it didn't manage to initialize the handle, it will try again with some different arguments. Arch2, that's interesting. Should be a dword access type. Is that so? Are all of these arguments even used? This kind of feels wrong. Sorry, I'm just catching up with the chat left and right. Alright. So we do see like a second attempt at creating a handle with a few different arguments. So we know that the second one should be DW access type. This case is being set to 3. I guess we could try and check the enum values for this one. If I have it like somewhere. Internet. Okay, so we see that 3 is through a proxy. Do I have this bad boy? We do not. So let's just add a comment. So we know that in this case, okay, so we try with the proxy first. If that doesn't work, we fall back to something else. Guess we could check in if there's any references. No. Alright, so in this case I guess we could call it internet open type, something like that. And let's set it as keyword. We see that the LPSC proxy value is 0x1BP. Does that look like anything? For 3, that could make sense. So we're giving it. Hold up, I feel like there's too many arguments there. 1, 2, 3, 4, 5. Yeah, there's a bunch of them. Alright, so we could look through assembly instead. This one or this one? Jump there. Okay. So which one? 2 or 3? And it should be. It's kind of messing with me because we're pushing a bunch of stuff there. Anyways, I won't get too into this one just because I try to keep this short. Does anyone have like a question? Don't hesitate to nod me while I'm doing this. I try to keep up with the chat. So if we continue lower, let's call this one, or I guess we could select proxy, no, proxy, H, internet. Oh, sorry. Oh. So that is kind of interesting because it does give us a bit more information on the other arguments. So we have, no, let me just rename that. Let's do something like that. So we have our open request right here. Let's go back to an SDN. Alright, so we know that we have our handle right there. So in this case, it's going to be using the unproxied handle. After that, we see that our first argument is going to be the verb. And as we remember, we did see a string containing just like post first, so this kind of checks out. So we can retype this one as being an LPC string and the verb. Our third argument is going to be our object name, which is a pointer to an alternative that contains the name of the target object of the specified HTTP verb. File name, executable module, a search specifier. This makes no sense to me. Guess we can pull off a quick. So I'm being a bit lazy right now. Is the path or object you're requesting from the HTTP server? Oh, okay, interesting. So it's like the query parameters. Or is it just the path? Okay, and before any query string fragment. Okay, so it's the path. Yeah. Okay, this makes sense. So we can call this one like path and set it as a, I think it's still gonna be an LPC string. Yeah, sure is. Alright, so this one, nothing, nothing, nothing. Accept access types. Do we have something on that? Or, oh no, sorry, is that gonna be the verbat version buffer accept types TTW flags? Okay. So what's going? Can we check for this? Do I have the wrong type? No. Okay, so we know that this is most likely going to be a combo of a few things. So we know that there's just, if we go by like kind of subtraction, we know that there's going to be internet flag keep connection. 1, 2, 3, 1, 2. Yeah, that will make sense. Okay, so let's just add a quick comment and say DW flags will be this, and then we have a Nate right after that, which would be no cookies. We have 1, 2, 3, 1, 2, so that would be 5. 1, 2, 3, so that's 4. 1, 2, 3. God damn, that's too small. Am I getting old? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, so this one would be the no cookie. So I guess we have. This would be 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, sorry. So it will be. Internet flag no cache write. Internet flag secure. And then we have another 8, which would be no cookies. Then we have B. So B is 12, right? 12 would be 8 plus 4, so I guess it would be those two. Hold up. So we say that we have 4, 8, B, 1, 0, 0. We say minus 0, 4, 2, 3, 1, 2, 3. Is that it? 1, 2, 3, yeah. Okay, and then we remove 1, 2, 3, 1, 2, 3. And then we remove this one. 1, 2, 3, 4, 5. Whoops. I missed one. IP100 minus 80,000. This leaves us with B100. And if I do okay, so it's going to be ignore redirect to HTTP, and then we will also have just use this one. Ignore set date and valid. And what else? So minus 2000. This is at 1000, so we can ignore invalid CNs. And finally, what else? Minus 1000. We only have 100 left, which would be no cache. And this makes sense. Alright, so we have our long list of shitty enums for our HTTP request. Alright, and this still returns an internet handle, right? Yeah. So let's once again call it a void pointer. I feel like this isn't an argument. Yeah, there we go. That makes more sense. Alright, so we see a second HTTP. Okay, so this is just opening the request, and then we actually send a request, which is going to be a different API. We can potentially extract more information from it. So we see that the 1, 2, 3, 4, 5. The fifth argument is going to be the size of the optional data in bytes. Okay, I'm guessing this is the actual optional data. It's only used for post and put operations. Okay, so this is the actual data that's going to be posted. So we can call it like post data, and then post data n. This one is going to be an LP void. Yeah. This one is just going to be a keyword. So this is starting to make a bit more sense. So that is fine. So we call RTL get last winter to error. So we want to see if this succeeded. So we can call that HTTP error. So I'm guessing this is still going to be an enum. Ah, that is pain. Alright, so I'm guessing this is some fancy error, so we'll just ignore that. Then we have internet query option, which could be still interesting. There's an internet option on the specified handle. So we still have our handle there. We know that var8 has to be an LP void as a buffer. And then this one is going to be an LP keyword as a buffer length. These two should be outs, right? There is an internet option on the specified handle. What else? Okay, so we do see that we are reading a file right there. So this could be pretty interesting too. We have a buffer right there. Let's call it internet buff. It should be void. It's to read, okay. That's interesting. Oops. Hold on. No, okay. So we see we just check for the length and then we close our handle, close our handle, close our handle. Alright, so what we can infer from that is that it will where is it reading it? Oh, interesting. Okay. Let's call it. The reason that I am calling this one our C2 payload buffer, and let me just retype this one too, is that what we are actually seeing here is that we are seeing the sample make a post request to a given server. And if that post request goes through successfully and it kind of receives a status that makes sense, it's then going to read a file and save it into a buffer and then return it. So what we're seeing it is just essentially communicate to the C2 to tell it hey, I'm expecting data, give me data, and then it replies back with some data. Obviously, let me know if I'm wrong, but I feel like this is right. So we can name this malware C2 get payload. This might be command 2 later on, but I think for now this makes sense. And there we go. So we see that it is being used on ipfi.org. So it is not only to the C2. So we could just call it fetch HTTP data. So we can then proceed, let's say, with this one with API.ipfi. So we do see a few interesting things within this function. Let's start with this one. Curious to resolve gaseous first. Any other ones? Sprintf again. Get computer name here. So I already have a gut feeling that this is going to be generating a payload that is going to be sending to the C2. Because we're seeing it's gathering information on the computer, on most likely its current IP, and a bunch of other things. So I feel like this would check out. We have this one. No. Okay, so let's call this one user agent. That's kind of interesting. Ooh. So I have a gut feeling that the user agent, the C2 endpoint is going to be saved as a registry key. But let's look at that. So we got open key right there. So we have our H key as the first parameter. Let's just rewrite it. Second one is going to be our subkey. Then this is UL options. Specifies the option to apply when opening the key. Okay. And this we have our SAM desired, which is a mask. Not that. What Frog says, during dynamic analysis, it also looked like it intended to reach out to multiple different domains. Yeah, this could make sense. Let me just grab Zen and pour myself another beer. So if you have any questions, this is the time. Yeah, this is pretty surprising. Recently, I also caught some, what was it? WannaCry samples, like original WannaCry samples, that people were apparently just like spewing out on the internet. Let me check. I'm curious to see what is going on in Twitch itself. Can I do ba. Oh shit, there's 12 of us, nice. Alright, so moving on, we see that we are opening a specific key. I did notice that the H key being passed with 0x8 whatever 1. So we could check that value first just to get an idea of which registry key that is. We can check in the rest, like documentation or the Ruby stuff, and there's like a few languages that give us more information than Windows does, which is nice. So you see that this is HKey current user. Hey, could I join the Discord server? I can send an invite here. Thanks for taking a look, Red Frogs. So this one we know is HKey current user. And then it is, okay, so we see that here. Oh god damn. Did I really do that? And Ari, just to give you more information, in this case, I happen to be doing a bit of reverse engineering, but the Discord channel that I am currently hosting is more incident response related. There's a few pretty good reverse engineering Discord channels that exist. One of them being OA Labs. Let me just share the invite. Yeah, I was mainly saying like regarding, you know, you said like learning, developing my skills in reversing analysis. So this one is pretty good, and another amazing resource that I do recommend is Invocari. Josh's training is absolutely spectacular. So I would recommend giving those a look. If you're looking at reverse engineering stuff specifically. And let me just post an invite to our IR channel. Oh, I do see your... Hold up, let me accept it. Cool. Alright, so what I was saying is that we do notice that things other than use agents are being passed here. So we could like name this something like load some weird string. And no worries, man. I don't mind. So in this case, we see that the third argument, and let's just not call this one use agent. Let's do like some freaking string for now. This one. Okay, so this is where I was. So it does fetch a subkey that we currently don't know about. We can look maybe after at the like resolution of those two variables. And we also see that the fourth argument is a global. So we can keep going with, let me just make this a bit bigger. In MSDN, let's search for rich query value x. So we know that first argument is going to be our H key again. So let's do some key. Then we have this one, which is a value name. Interesting. Which query value XA? Retrieves the type and data for the specified value name. Okay. This is going to be a value name, and it is going to be an LP C string. Then we don't use this argument. The LP type we know is going to be LP dword. This one is going to be okay. So this is going to be the data within that value. Let's call it key value, and we can say that it is LP byte. And finally, a PCB data, which I'm guessing a pointer to a variable that specifies the size of the buffer. Yeah, okay. The key value then. And this one should be an LPD word. Okay, so this is already starting to be fairly helpful. Let's just check. Let's show exactly what the fifth argument. Oh, okay. So if the key value length is smaller than it runs. Okay, so it's expecting 129 bytes as a length. Sorry. Yeah, 0x81. This let's do expected value, or we can say like minimum. Okay, so let's call this one like load value from reg key. Let's go back to where it was called. And let's check how it's being used. So it's going to be saved to a global. We see it referenced in sprintf, so there's some debugging going on there. We also see it being called as the last argument of that function. So we could check what it's going to be doing with this. Let's just tweak this a bit. This is not going to be reg1. So this is fine. We can look at this one. Okay, so just looking at the APIs that are being called, we can take like a wild guess that this is just stocking a value in a registry key. So this is going to be our H key. We can go and get this one again. We have our sub key. And then second to last, going to be PHK result. Sure. So here it's just closing the key. This one is setting the actual value. This one's fine. So let's call it key value. Second view. 1, 2, value. Key value name. Our second to last one is going to be the data. Key value data. And then, and this one was the const byte pointer. And this one, let's call it data length. Value data L. So this is already starting to make a bit more sense, where we see we are just writing to a key, so we can most likely call that like set h key. arg5 is unused, arg6 is unused, arg7 is unused, so we can tidy up that mess. That's a bit cleaner. These are unused. We have a result right there. Just set to bx1. Okay, which is essentially just checking the result. Function succeed to return value error success. Can check what kind of type that is. Let's do like okay, so it's going to be an empty status. There we go. Status success. And we are checking what's SPP. Check at our car right there. It's moving through there. Okay. We're pushing the result. Doing a negative. It's just looking at a byte. So just returning a boolean. Yeah, okay, this makes more sense. Let's just call it a boolean. Alright, so we have this function figured out. And it's interesting because we do see that is being used a few times. In this case, it was being used with our global that we had mentioned previously, right there, which is referencing another registry key. So that's somewhat interesting. So we can try resolving this one. UI to create there. This one is going to be a UID pointer. What was this messy? Fuck. That's a horrifying string. Okay, so we get a computer name. Oh. Oh, that's interesting. Okay, so I have a feeling that this is actually going to be the payload that is sent to the C2 with like a bit of encoding, quote unquote. Let me just get back to this and that. Alright. So let's call it like data buff. Yeah, so it's creating a string right there, which is a bunch of information. That's fine. We get a computer name, and then we pass it to this printf. So let's call it G data buff. Yeah, so it's interesting. It loads like what is most likely a string of at the very least 129 bytes long. It saves it into a global. It then proceeds to create a UID, so let's call it like UID. Real creative there. And it will then use that UID into the payload that it is constructing there. It then fetches the computer name, and is it going to be appending it, or is it going to be overriding it? Let's ask a good friend. Say printf on here existing string, append to it, or override it. Okay, so it would be overriding. Maybe we're missing something here. Oh, okay, so the data isn't lost. Okay, so we just like read a bunch of shit, and then we use rsprintf there to write to a data buffer, and then we start by writing our data buffer. After that, we add in these 2 bytes, whatever they are, and after that we write our computer name. That's kind of interesting. We see GR there. I wonder if that's like an identifier for the like quote unquote C2 user, or like the specific sample that's being used. Let's call that maybe sample identifier. And then we have a computer name, yeah. And finally we are going to write all of our payload into a specific registry key, which we see it's using 3 and 4 there. So one could guess that it's fetching the same value. So it's just like updating a specific registry key essentially. Yeah. makes sense. So in this case, this is gonna be a get, so we can do like jar 0 x4. Cool. So we are making a get to ipify.org. And we, so let's call it p payload buff. Let's rename this one. No, HTTP result buff. Actually be an LP1. Alright, so we are fetching some data from api.ipify.org, and then we take the response from that and we do some stuff with it. I feel like it's just parsing the IP address. So we're checking. Yeah, we're checking it like character by character, right? Yeah, I feel like that's it. Okay, so we'll just like validate. Yeah, and it's just returning like a boolean. Then we are getting some adapter info, and we are allocating a yeah, string for it, I'm assuming. It's kind of interesting. Okay, interesting. So this is going to be a bid adapter info, which we currently don't have. Let's see if we can't import that. Do we have it natively as a pointer? We don't. Nice. So we are getting a structure that contains some information about our adapters. So in this case, this is, when I say adapter, it's like network adapters. So if it does not equal 0, so if we have some adapters, it's doing some stuff there. Not sure what it's iterating on exactly. If you guys have a guess, let me know. Yeah, like adapter. Say the type. Ethernet network interface. That's kind of interesting. So it's trying to, it's doing something different based on the adapter type. So if it gets 0, okay, so if it's empty, it just like skips. Otherwise, if it gets an Ethernet adapter, it breaks out of the loop, which is there, so it continues on. If not, just continues cycling. So adapter IP. Yeah, so I feel like it's just searching for an Ethernet adapter. Then this might just be like a flag. It doesn't seem referenced either. Alright, so moving on. I don't see it making like, it doesn't seem to be like posting any data. It just seems like it's initializing data about its victim, and then like storing some information about it. What is it called? Just gets called in our start function. It's kind of interesting. Yeah, so let's call it for now like edit some data in rich keys and get adapter info. Longest name, but at least, you know, it's clear. Cool. So let's get back to our start function. I guess we could look at this one. That's nothing too fancy. We're just sleeping. And it's doing like a bit of math to determine the amount of sleep, so we don't really care about that. Uh, guess we could try and catch this one. Oh. Unresolved stack usage. So let's just take a look at that first. Let's go into our low level IL, into graph view. Let's see where it's breaking. Okay. Oh, okay. Okay, so we can just ignore this for now. So if we look at the hashes again, good old trusty sprintf. Got another one there, create file A. And then we're messing with some more registry keys. So in the peb, process parameters, image path name, and then buffer, if I'm not mistaken, that should be the current file name. Alright, so I'm just gonna pause this for a few minutes. I'm gonna go to the bathroom real quick. If you guys have any questions in the meantime, just let me know. Alright, any questions so far? Something like that? Alright, so this feels just like a general registry key initialization. Sorry if I don't pronounce everything correctly, by the way. English is not my first language. Yeah, so it does feel like it's just initializing some registry keys that it's going to be using later on. Fuck off, wet frogs. Okay, interesting. You do see like just 2 bytes being used there, so I guess we could like quickly retype that as a so it should be like 3 because we want the null byte. Or do we? Maybe we don't. I don't think we do. So we're calling sprintf. Yeah, okay. So it's just saving its current file name into a variable. So we could do like a current file name. And then we have this function that is loading something from a string. I'm gonna have to figure out this one. This is stumping me a bit because it does seem to be like I feel like it's a table of strings or like an array of strings because we do see like gate.php. This is pointing to a string, so we see that it's like whatever this is. You also see like this, which is interesting. Yeah, I feel like there's a few strings that are a bit mangled right now. No worries. Let's keep going. This is interesting. Let me just try and Google that real quick. What about this one? Okay, so it would be Hancitor. Interesting. And we do see the similar pattern of like setting up registry keys, whoops, for persistence. We see our gate.php calls. And we see the sleep that we skimmed over briefly earlier. Cool, that's kind of interesting. At least we know like the exact sample we're working with. And this was published in 2015, so that is not young. Cool. At least now that we know exactly what it is, we can, use some online resources to kind of guide our reversing too. Let me just see if I missed any important message. Am I being shit posted down by Becky? No, not good. Alright, so moving on once again. We'll come back to this one. I think this one will need a bit more attention. So we can look at this one. We have a bunch more imports that we can resolve. We see some environment strings, which is interesting. Directory creation, getting errors. Copy file W. This is going. I feel like this is going to be. Yeah. There we go. So this is actually interesting because when I initially tried to run the sample dynamically, I didn't notice that the file was essentially saving itself elsewhere as winlogon.exe, and then it would re-trigger itself into a new process. So this is what we're seeing right there. So we could say that okay, it's going to be some white chars. Okay, let's just tackle this after. We have this one, the doc again, this printf, when exec, there we go. So this is probably going to be what is going to execute like itself with the new name. And then we got local free. Cool. So expand environment string W. Let's look at this one first. Can maybe switch up the music. What do we want to listen to? Alright, so this one is going to be our source path, which is data windows, and then we will have our destination path, which is going to be an LP Y string. Let's call it test. And then we are going to have the size of our string. So we could say that, yeah. Okay, so this makes a bit more sense. Where we are just appending, yeah, we're just appending that. Okay, so we're creating a full file path. Okay, so we couldn't, and how is it reading from itself? We have our WinExec there, we have our copy file W there. Okay. Let's call it like current file. We have our destination, which is going to be there. Okay, interesting. So it's just like copying paste on the file name rather than the actual content. I guess we could validate that through MSDN. Copy file X function provides 2 additional capabilities. Specified callback function. This we don't care about. Okay, copies an existing file into a new file. Okay, there we go. And then we have our WinExec right there, which is going to be a string with a bit of this logic, its current file name, and then the destination. So we can like take the wild guess. Oh, there's a bit more there. That it's essentially just executing itself and then sleeping for a bit. Yeah. Cool. And then yeah, okay. There's a file. Copies the file, it sets the result. I guess we could like call this like or persist or whatever. Let's go back to there. Okay, so this one is going to be persist. This one is, ooh, okay. So it is creating a mutex. What's the name it's currently giving it? Okay, so it just like loads it from a list of strings. So it creates a mutex. Typically the reason why it does that is that later on in the logic it's going to check if the mutex exists. So it can't like be spawned multiple times because you just want one instance of your beacon or your malware sample to be running at a given time. So we could just call that yeah, it's still just one, so this is going to be boolean create mutex. Making this a bit cleaner. There we go. Okay, so we get our current file name, we create a mutex, and if it succeeds, we also set up our persistence. And if all of this succeeds, we are moving into our file creation phase. So this wouldn't be persistence, would it be? It gets its current file name, creates a file. Just check. Create file it takes. So this one is just going to be a file name. With 3, which would be the security attribute. 1, 2, 3, 4. The creation disposition. Fuck is that? 3 would be create new and create always? No. Okay, open exist. Okay, so it creates the file and then it opens it. If it doesn't exist, opens a file or device only if it exists. Okay, interesting. So it's using create file A to just open a file. Is that like a normal thing in Windows? People actually just, why would they call it create file A if it's just opening? Anyways. Okay, and then it sets hold up, what does it return? Freeze or open or a file or IO device commonly used for file streams, directories, physical disk, blah blah blah. Creates a transacted operation which results in a handle that can be used as a for the transacted IO. Interesting. So it returns a handle. Okay, interesting. So we could look up this registry key. What's it gonna be? H local machine. Once again we get a subkey, we get a key value, and then we save the path of our file so itself into the registry keys. We fetch another string. And we do that again. Okay, so it's okay. So if this fails, it then falls back to which was the current user. So that's a boolean. So it's gonna return that. And if it couldn't create the mutex, and if it couldn't create like its persistent file, then it just exit, which makes sense because it either can't do what it's expected to do or is already running on the machine. So this makes sense. So this wouldn't be, this would be like create self file, like establish persistence, core beans. So we can go back to our starting function. So it tries to establish persistence. It initializes some data. What now? Guess we can go into this one. So we remember that we had written some stuff to our gdata buffer, our global data buffer. So we could look at what this function does. Okay, so it's making a post request to what is arguably our seek2. Hold up. Yeah, I feel like I'm gonna have sooner or later have to unmangle all of the globals. that's wrong. Yeah, completely off, yeah. That's our server name. There we go. Okay, so we are creating that and that. A string right there. That is then also used with some other stuff to create our final like server name. As I like gut feeling we're creating like a kind of either like IP address to port mapping or like domain name to port mapping. And then we're just like posting some data to it at this path. So I guess we could rename this one to path post data len HTTP result buff and bytes to read. Okay, so this is making a bit more sense. And how was it being used? Okay. Interesting. So let's see how it's being used by one of them. So you see that we are posting our global data buffer that we had noticed that it's kind of filling initially. We are saving our HTTP result buffer with a length of like 100. So we know that the payload will most likely be under 100 bytes. Well, 0x100 bytes long. I feel like that's going to be a stretcher. And this is kind of fucking with me. Alright, so let's get back to this one after and see if we can chew through a few other things. Alright, so we are getting a temp path. We can once again check this. And you'll notice I'm using MSDN a lot because it allows us to resolve a bunch of types that will then get like propagated throughout the program, which makes the disassembly much cleaner. So it's like it's a bit tedious, but it's really worth it. That constant it's compared to looks really familiar. Which one netcats are? They're saying that was posting and comparing a return value. Hold up. This one. Alright. I feel like you know what this is, but... Oh, interesting. Hancitor goes the extra mile, blah blah blah, the onion route. If d word is equal to this, it continues the communication, otherwise it goes to sleep. Interesting. Yeah, I had a a small feeling that you knew it. Okay. I'm just curious to check on if we have anything on Mappedia on this, because we know it's like Chancitor, or like let's just call it Hancitor. Yeah, so maybe you missed this initially, but it we ended up kind of confirming that it was Chancitor, which I'm assuming is a variant of Hancitor. Chanitor, sorry. Okay, so Chanitor is just another name for Hancitor. Okay, my bad. Yeah, so it is Hancitor. I guess we could check this one. That link. Oh, which one down? I think this one was just on the backing though. Is it? Yeah. Hancitor extractor. Hancitor loader. This could be interesting. Nah, no worries. Jesus, that is a well documented piece of malware. Anyways, it still gives us a good idea what's going on. Okay, so we see FD. Oh, interesting. Okay, so that's the string that we saw being built earlier. So we had noticed that it was like passing a UUID first. Hold up, let's try. Yeah, as you said, it is cheating. So if we look into our string creation, we did notice that this is pretty much like the pattern that we're seeing there, where we have at first 8 bytes, and then we have a sequence of 4 bytes, 4 bytes, 4 bytes, and then a longer byte, which, as we remember, references the UUID that we create initially. And then after that, there's like a bunch more stuff, which was like right there. So we could call this like, oh, I wonder if that's not a UUID pointer and it's just an actual UUID. And there we go. That is much cleaner. Alright, so we see it's essentially just like populating the UUID into the string. So yeah, thanks for the hint, Nitkat. Alright, where was I? At this bad boy. So we see that it is loading something from a temporary path. So we get a temp path there. We also fetch a temp file name. So gut feeling this is going to be writing something into a temporary file. Yeah, hopefully it's a new variant, but so far as Wetfrogs initially said, it feels very like old and known. So I got a good feeling it's maybe just like someone experimenting with an older sample. I don't know if you guys know or not, but let me know if the code to Hancitor is known to have been leaked. If it's been leaked like somewhat recently, maybe someone is just like fucking with it and seeing how far they can go with it. I guess we can check into detected easy. Yeah, okay, so it really is just like an old sample. So yeah, weird that, it got picked back up by the Wetfrogs, but yeah. Maybe I can just like skim back over the context that was provided to us by Wetfrogs on this one. Let me just get back the GitHub link to it in the chat. So I feel like potentially more people have joined, so we can go over this quickly. So in this case, it was we know that it was distributed using a watering hole attack, and it was targeting specifically a resume collection application. So in this case, so Salesforce isn't specific to resume collection, but I'm guessing the person that ended up receiving this was using like a resume collection plugin that was then feeding data into Salesforce. Uh, the application is an HR tool, blah blah blah, which can query resume scraping service in order to automatically create a pool of qualified candidates. So I will like do a small tangent, but Salesforce, I hate you. Forcing companies to pay for security features is an absolute dick move. And if anyone watching my stream works there, I will kindly say fuck you. So the way it was found is there was essentially a zip archive that contained an SCR file that was disguising itself as a PDF, so like impersonating her resume essentially. And it was then dubbed by Wet Frog's Crocodile Rock, but in this case we now know that this is Hancitor or Chanitor or whatever you want to call it. So going back to our sample, we know that we are now calling, okay, well, I think it's good context. I wasn't too familiar with Salesforce. I had to ask HR where the hell they got the sample from, and that sent me down that rabbit hole of them explaining it. Yeah, so the TLDR of it is Salesforce. This is like a kind of generic corporate tool that companies tend to use for a bunch of stuff. Oftentimes it's used to track like sales leads and things like that, or gather information on your customers or your staff and things like that. It's like super big, and it is not a small company. Of course, if we look, let's just check Salesforce revenue. So in 2023, they had $31 billion in revenue. So it is, yeah, not a small company. So going back to this, we know that we have a path name. Then we have an LP prefix string. What is that? What Frog says, oh interesting, I wonder if they were using some resume plugin or if it was just something that integrated with the Salesforce. I may be speculating here because I don't know the ins and outs of Salesforce, but I'm like 99% sure that it requires a plugin and that it's not something that comes out of the box with Salesforce. So this being said, we know that this global variable should be an LPC string, which is going to be a LP prefix string, which is the null terminated prefix string. The function uses up to the first three characters of this string as a prefix for the file name. Interesting. The string must consist of characters in the OEM defined character set. Okay, sure. If we check, we do have 3 characters right there. So we can just quickly rename that. So it's going to append the temporary file name with 3 underscores. So this could actually be a good indicator to use later on. And then we have our final temp file name right there, which is just going to be an LP string. So it feels a bit weird to see like this variable being used twice in the same function, but whatever. Let's just take a look. There we go. Okay, so it's just like building something.exe and as a temp file. So we know that our temporary file will be like 3 underscores, some value, and then .exe. So we then proceed to do a local alloc, which, if I'm not mistaken, this is going to be like the final length. Yeah, it's going to be the number of bytes, and then we have a flag right there, which is going to be 40, which is mm0 in it, so we 0 initialize the content of our variable. And then, yeah, it's just 40, so it's just that. So I guess we could set it After that we have, let's just call that buff. SI1, which is being used right there, which is pointing to what is seemingly an MTA. Potentially, yeah, this might be like a pointer to something at some point. Just skip over it for now. So we iterate over this value. Okay, so it's just getting the length of a string. And I will show you my next trick that is very helpful when I'm a bit lazy. Is this just returning the length of a string doing something else. It's not just returning the length of a string, interesting. So it's traversing the string and counting how many characters per. Similar to the behavior of string length, oh shit. With a slightly more complex implementation. So one character at a time, it increments ex, each character in the string until it hits. Returns the value ex, which will be the length. Okay, so yeah, thanks to GPT, this function is not just returning the length of the string, it's returning the length of the string. Nice. So we could just do like a quick string length. So we can do recall that by just like buffering. Yeah, thanks AI overlord. So moving on, we have this weird function that was preparing another buffer and posting to our C2 server. So let's just like be a bit lazy for now and call that post to C2, and then it gets a result. Is this an old value? Nope. What is it returning? Let's okay, so we have our printf there. We get the string length of whatever this is. And then we make a request, which, if I'm not mistaken, return interesting, sometimes here, so that's just going to be 0. Okay, so it's going to return just going to return like a narrow code. It gets the number of bytes to read. Just recheck that real quick. Yeah, number of bytes to read. It's kind of weird because we only see it returning either, you know, what is presumably 0, or what else? FFFFFFF. While in the function that was just calling it, we are seeing it. Okay, no, my bad. I think I was tripping. Yeah, so it's just looking essentially for either -1 or 0. feel like this is just some like return payload validation routine. So going back, so we see that we are posting some data. If it is, okay, so there it was. So our result right there can be, the fuck. I feel like this is wrong. Anyways, I won't get too tripped over that for now. So then we check like some result. If it's less or equal to this, which is okay, just a big old number. We go ahead and we create a temporary file. Is that going to be a flag or is it file size? As we see, 1, 2. DW desired access. Do we have something there? No. DW desired access could be generic read, generic write, or both. I feel like it's gonna be generic write. Yeah, there we go. Okay, so that's just generic write. Moving on, so we are creating our file. And what other variables are being passed to it? So we see flags and attributes, we're giving it 0x80. Which is 0x80. And then this one, which should be creation disposition, which is going to be create always. Fantastic. So we know that it is always going to try to create that file, and then our return value. We get a handle. Okay. Is there such a thing as like an H file? We check if the handle is valid. If it is, go ahead and write a bunch of shit to it. So we write the content of the buffer into our file, and then we save. Okay, so that's going to be our length. Just call it buffer, and then where 10 is something. Okay. So So we look at write file, and it's the np helpful as ever. So we got our buffer, which is fine. So we can, I guess, retype that to an APC word just to be nice. Our buff length should be a keyword. And then the number of bytes written. And I guess we're just going to be making like an assertion after that to make sure that we have written the right number of bytes. This one would be a boolean. Sure. So that's fine. And then we close the handle to our file, and we call local free in our buffer. So unless I'm mistaken, one could assume that what this is doing is fetching data from the C2 and dumping it into a temporary file, essentially. So fetch payload from C2 and write to file. Very explicit as always. So that is fine, and we know our first argument is going to be our post data. So now for this one, I'm going to take a wild guess and say that this is executing the file that it downloaded. Oh, surprise, surprise. Okay, so let's call it exec file 2. Because it seems to be doing the same as the other function that we have noticed. And it's going to be returning probably a fucking boolean. No. Okay, it's returning something. So we execute our file. We have more stuff there. Oh, it really loves executing stuff here. So we... Yeah, this feels like a reg key. So we can look at this function. And to absolutely no one's surprise. Shouldn't that be a D word and not an LPD word, since the address of non-written bytes is being passed in? I think you're right. Hold up. It's still gonna work anyways. So let's stick back to our reg keys. Let's fix the calling convention real quick. Unused, unused, unused. This one is used. I think we can just remove the last 3 arguments. Not sure why sometimes Ninja struggles a bit with function signatures. There we go. Did it clean up a bit this one? Yeah, there we go. This is much cleaner. Okay. So we have our key, what is most likely either like a subkey or a key value name, and then something, or maybe like this is the subkey and this is the key value name. So once again, we go back to this bullshit of retyping everything. I'm just gonna take a wild guess and say this is an H key. Reg open key, this is probably our subkey. I can't recall what the type is though. LPC string or C string. Let's call it subkey. And then we have some options where we use nothing, and then our some desired. Or some desired. You can just check this one. we already have like a 2006. Yeah, nice. So that's just key run. So that's fine. We're writing into a key of an unknown value. We then proceed. Oh, maybe it is taking a few more arguments. Measure delete value. So this should be an H key. And then this one should be the value name. Then we close the key. Like a bit weird at that. Let's take a look at the assembly. Yeah, so I think we only have 3 arguments. But why would it be? A question from Nitkan: is there a way in Binja to import types similar to how IDA can import WinSDK types? Yeah. So when you go into your types, let me just close the symbols for now. You can essentially go into either like the user-defined types or the system-defined types. And in this case, I was being, a bit lazy, but one could just like either click on type library, or then you could also create your own. Was wondering, since a few constants were there for you and you had to make comments. Yeah, I think I'm just being a bit lazy on like finding in which header file these are named, and so I'm just adding the comments. But normally the second you like import them, after that you can just like go and click on M, and then all of the enum values are going to be populated there, and you can just pick and fill it. But yeah, I'm just being a bit lazy. So this is fucking with me a bit. No problem. So we are deleting a value to an unknown key. So I feel like, yeah, see, this is wrong. Okay, and this is, okay. So I'm pretty sure it's going to be taking 4, let's just do like a word pointer there. And let's just fix this one. Why is it R-ing it with ESI? Keep running it. Okay, maybe it did take a few arguments. Okay, so it is actually doing an OR. So that this function can take like variadic arguments? Don't think so. Oh, hold on. Oh, okay, sorry, I completely missed it. Yeah, so it's opening a key, and then it's deleting the value from it. Okay, so I missed it. So let's call it like fucking key, whatever. Let's just make these two bad boys equal. I never remembered the order I should be using. No, let's just leave it as is. And then it's closing the key itself. Yeah, okay. Okay, so that's interesting. So it opens a key with a given subkey, and then it just goes on to delete a specific value that is passed in as an argument. And then it closes the key and presumably just returns like a boolean to indicate the status. So let's just call it like malware delete key value. Moving on. No, sorry. Okay, so that's our WinExec, so we can look at WinExec again. I did see that it sets some strings to then run and startup keys, but when I physically checked, they looked empty. Yeah, maybe it's just like setting them temporarily, using them and then deleting them to prevent you from being able to like see them being set. So it's trying to be a bit sneaky, but I'm just speculating there. So we do have our WinExec there. P command line. We could just call this one command line. It's going to be an RPC string. So it's just going to be. Let's leave it as such. And WinExec, what does it return? If the function succeeds, the return value is greater than 31. If the function fails, the return value is one of the following error values. So you have invalid exe, file not found, specified path was not found. What's the value of this? Is it okay? Error success is 0, so it's the one below. So this would be 11. I guess we can just leave it as an int32 for now. Okay, so recap, we are getting our own file name. We are creating a buffer and populating it with some information. We are deleting some key values, well, some sub-key values. To answer your question, netcat, it's being called in the start function, so in our main routine. It is getting like somewhat close to the end, so maybe it's just trying to execute something. Hold up. Running is printf. We are populating a value name. We are deleting this value name. Load another one, we're deleting that, and then we WinExec on our command line, which was created from that string. Okay, yeah, so it does feel like a like cleanup routine-ish, where it's like wiping those two registry keys and then executing something that might be populating them later on. Yeah, I really have. I'm going to have to figure this one out. So for now we can call it like wipe key values and exec. So we check if this has succeeded, if it arguably hasn't. Could probably just set this one to yeah, we're going to call it this one. Okay, interesting. Which functions have we not resolved yet? So we got this one. That doesn't contain much. This one that posts some data with the command that Nitcat pointed out earlier. We have this one, which is preparing a string like this. We have this one. Okay, this one we just saw. Some data manipulation. More data manipulation. Again. This rings a bell. Oh, that's interesting. Ooh, okay, so we have like knee-jerk reaction tells me that this is going to be process injection. So Red Frogs, you left at just the wrong moment because he was talking to me earlier about the sample potentially doing process injection. Let's just do that. Okay. So EDI in this case. Yeah, exactly. So I'm tempted to say this is going to be a DOS header pointer. Yeah, this is going to be our empty image header. What is it? Empty headers. Well, we have our signature. Something. Nice. Cool. Okay, so this shouldn't be too hard. So if we go at it. I'll just start by retyping my variables there, because that's going to make my life a bit easier later on. Okay, so that's going to be your application name. That's going to be our command line. And this is going to be some startup info. Okay, sorry. Okay. This is going to be our process information. So let's call that startup info. This one proc info. So this is making a bit more sense. We have our anti-get context thread. So this is going to be a handle. This is getting way too wide. This one is going to be 3FP context. Nice. Context. Let's continue on with virtual memory once again. So this is going to be a process handle. We have base address. That's interesting. I'm not super familiar with context. Map stuff? There's just yeah. Oh, okay. Okay, interesting. Yeah. Okay, because we are NTM map right there. Let's just try to expand this a bit. Yeah. Okay, so this is going to be a base address. Sorry. And it's going to be a P1. Oh, okay. So if we let's just relook at that. This one. So we have. I'm guessing this is going to be our base address, at least at the site. Number of bytes to read. So it's only reading the first 4 bytes. That feels wrong. Hold on. So I have our process handle. We have a base address. Okay, so this would actually be our buffer. Okay. Let's call it buff. And this is going to be a P void, which is right. Okay, so it's going to read the first 4 bytes into our buffer. Why would it only read the first 4 bytes? Okay, anyways, let's not get too stuck up on this. That's fine. If the base address is equal to the pointer to our image base, which makes sense, we unmap the section. We allocate a bit of space for it. Just make sure that our typing is right. So we have, yeah, like our process address. It should be the size. Right. 1, 2. Oh, sorry, I have the wrong. Okay, there we go. 1, 2, 3, 4, 5. Yeah. Okay. So that's why I protect the allocation type, the actual size, the address at which we want to allocate the memory. Yeah. Okay. Yeah. Cool. And this will be returning the base address of the allocated memory region. Okay. So that's going to be a nice P1. So we would then proceed to write process following. It's common to use the thread context EBX plus A to get the image base address since the PEB. Oh, interesting. Okay, that's good to know. Thanks a bunch, Nitcat. Super interesting. Okay, I'll give a better look at the thread context afterwards. I'm not super familiar with it yet, but that's great info. Alright, so anti-virtual write. So we have our process handle, we have our base address. Let's set it as that. Okay. Right, base address for analog, just to make it a bit clearer. And I mangled the name. And then EDI in this case would be a pointer to the buffer that contains the data to be written. Okay, interesting. Let's go like buff to inject. Let's go with that. And because okay, yeah. So it's essentially just injecting itself into another process. Because we see what we define as buff to inject is essentially the DOS header to itself, well, potentially itself or something else. And we do see it injecting it into the process. So I'm still, oh, okay. So this function allows you to create like essentially whatever process and inject the current malware into that process. So let's continue just to make sure. So we have our size of image. That's fine. We write our virtual memory. That's fine. R3, which is our DOS pointer. Okay, so if it was unable, if it's not equal to 0, let's just check what's the return type. So this would be an empty status, right? Let's just double check. Okay, yeah. So if it succeeded at allocating the space that we need, it then proceeds to write it with the size of the headers, and then we just null out our executable. We check the number of sections. Okay, so it's just iterating over the entire binary and writing all of it. Interesting. And then we just close the main off. Okay, so I guess we could say that this is like a spawn process to inject or whatever. And inject. So this brings us back to yeah, same. It just seems to be like writing the thing as is, but we did notice, if I'm not mistaken, in Detected Easy that their relocations had been stripped from the binaries, or from the binary. I'm just trying to find where we were seeing that. Yeah, so we do see that the Redux and it has like the Redux thread flag. So I'm guessing this is why it's not trying to handle it. So yeah, there's that. So I think this sums it up with this function. It might be still like a bit mangled in Binja because we don't see that function being referenced. But I'm assuming at some point it's going to trigger it. Okay. So we still have a bit of work to do, but I will need to research a bit more the rest of the stuff. And we are coming up on 3 hours on our stream, so I think I'm gonna call it quits for today. So let's just save that for a future reference. Let's discard this one. Yeah, thanks a bunch, Edcat, and thanks a bunch for the help. And thanks to everyone for showing up. I know it was requested that I record it and post it somewhere, so I will figure that out. In the meantime, let me just... yeah, thanks a bunch for the comments, guys. I will repost the link to the DFIR Discord server that I host. Let me just get it if I can not be such a boomer where I can't even find how to invite people. So let me post this. Also, a few shoutouts are in order, just to some good friends and people that helped me. So the first one, if any of you guys are looking, for some deception strategies, I highly recommend reaching out to these guys. There's also Josh at Invocari that does some absolutely amazing content in terms of reverse engineering classes, and his community is absolutely stellar. He's the one that kind of brought me from 0 to where I'm at today, which is not too far off from 0, but it's still something. And finally, a quick shout out to OA Labs. Let me just get their Discord server, because I did have a bunch of help from everyone in their community over time, so I really appreciate it on that. So thanks a bunch, guys. I think I will leave on this note. I appreciate all of you guys showing up, and I try to make an announcement elsewhere, somewhere, if I end up doing a second part to this one. So thanks a bunch, guys. See ya.